the quadrilaterals and then you applied it, that's what you're going to do with circles. You're gonna learn theorems and how to do with circles, and then they'll give you problems where you're going to have to put all those theorems together to solve what they've asked you to solve. The very first theorem has to do with that illustration over there, and it says this. In a circle or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. Now remember, the chord is the line segment between 2 points. So if I say this is congruent to this, then I can automatically assume that the measure of arc AB is congruent to the measure of arc CD. The converse is also true. If they tell me that these two are congruent, I can automatically assume that the line segment AB is congruent to the line segment CD. Okay, does that make sense? All right, the other thing, and this is an illustration that's farther in that section, if these two chords are the same distance from the center of the circle, okay, so if let's say I know that this is 5 centimeters here, and this is 5 centimeters here. Okay, if those chords are the same distance from the center of the circle, then those chords are congruent. Okay, that's a third theorem, if you will. The second theorem is over here. The second theorem says, in a circle, if the diameter or radius is perpendicular to the chord, which means it forms a 90-degree angle, then it bisects the chord and its arc, which means that is congruent to that, and this is congruent to that every single time. But it has to bisect it or form a 90-degree angle there for it to work. Okay, so those are 3 different theorems that have to do with circles. Now, there's other terminology here that we've got to pay attention to. If I said I had a square inscribed in a circle, what would that picture look like if the square is inscribed in it? Would the square be inside the circle or outside the circle? Inscribed is in the circle. So if a square is inscribed in the circle, then it would look like that. This is inscribed. But if I said a square is circumscribed, around a circle, then I'm going to have a square on the outside and a circle on the inside. Okay? So inscribed, if I said a triangle is inscribed in a circle, then the triangle will be inside the circle. If I said a triangle is circumscribed around a circle, then the triangle would be outside the circle. So you got to make sure that you've got both of those terminologies, okay? Now there are, but we're not going to do it, there's proofs that can be written with these, but we're not going to be doing proofs. There's enough other stuff to do with them. So let's do a problem that might have something to do with this stuff. All right, let's say I got circle O. Oh, terrible. And it tells me the radius is equal to 13 centimeters. Okay, tells me OB is perpendicular to CD, and it tells me that CD is 24 centimeters long. Okay, it wants me to find the measurement of CV if the measurement of CD is 134, and it wants me to find OX. Okay, so we're going to look at this based on all that stuff up there. Okay, I have a radius of 13. Now the radius is from here to here, right? That whole thing is 13. Don't make the mistake and just take it to that spot right there. I know that CD, that whole thing, is 24. So what do I know about each side?
They're congruent.
They're congruent, and if the whole thing is 24, what's the measurement of each side?
Half of that.
Okay, so 12. So this is going to be 12, and this is going to be 12. You with me? Okay, I need, okay, it also tells me that CD, which is this whole section right there, is 134 from here to here, right? The first thing I want to find is I want to find CB. So what is CB going to be?
Well,
CB,
it'd be 90 maybe.
it's going to be that. How am I going to find it?
Take half of 134.
Take half of 134. Is Rebecca the only one awake in here right now? Okay. 134 divided by 2 is going to give me 67. So I know that the answer for this is 67 degrees. Okay? Now this other part, that's a little bit harder. Okay? I want to know from here to here. So we'll call it Z. Okay? Any idea?
Well, the whole thing you said
The whole thing is 13.
was 13.
But I don't have any way of finding from X to B. It didn't tell me X to B. Any guesses?
6?
I'm going to form a little triangle here. What's the distance from here to here? What is it?
13.
How do I know that?
That's the radius.
Because that's the radius. And any time I draw from the center of the circle to a point on the outside, that's a radii of the circle. So this is going to be 13. Is there any way for me to figure out what that is?
You can do the a squared plus b
The
squared.
Pythagorean theorem. This is my hypotenuse. So it's going to be 12 squared plus z squared is equal to 13 squared, right?
Mm-hmm.
Okay, so 144 plus z squared is equal to 169. So z squared is going to equal 25. So what's z going to be equal to? 5. Okay, so I know from here to here is 5. Obviously, this is not drawn to scale. Okay, so if that whole thing is 13, and let's say they wanted me to know from there to there, that would have to be 8. Okay, does that make sense? So you're basing on what you know from the past. Okay, I'm gonna give you one of these to try. Okay, because Rebecca's falling asleep on me over there, so she needs something to wake her up. Alright, that's the illustration. Radius of this circle, which is circle W. Okay, the radius is equal to 10 centimeters. This is perpendicular to this. And HK is equal to 16 centimeters. the measurement of HL is 53 degrees. I want to know the measurement of MK. And I want to know JL. Okay, so those are two things that you're doing from this. Okay, I know the measurement of HL, and I want to know the measurement of MK. Now be careful on that.
Got two. What's that for?
Okay, from W you should have.
Oh, I used 16, not 10.
Oh, gotcha. No, the radius is 10, so yeah, that would be the. Those are your two answers. So what you got, Ally, on 27 and 4? On either one of them?
I didn't get MK.
Okay, you did get JL. Okay, if you look at MK, if you go, this is 53, this would have to also be 53, okay, because those two are going to be the same. It's asking for this. Now
I
from
put
here,
53 as like the angle, not the.
gotcha. Okay, it's got a arc over it. Okay, so if you look at it, this whole thing, you actually, the angle, it would be MJK. You're not going to do an angle with just two letters. Okay, so you would do 180 minus 53 is where you got that. Okay, we good on that? Okay, that is section 10.3. Section 10.4 has to do with inscribed angles. Remember how I told you that there's a difference between central angles and inscribed angles, and they're going to start putting these together, and you're going to have to remember. Okay, inscribed angles means that the vertex is actually on the angle. Okay, so let's say this is angle A, B, C. The measurement of angle ABC is equal to 1/2 of the measurement of the arc that it intersects. Okay, see how this goes up like this? Let's say this was, I don't know, let's say this is 100 degrees from A to C. That means this down here
It's 50.
is 50.
Okay.
Now, what's the central angle?
Central is the ones right in my phone.
Okay, what's the difference between the inscribed angle and the central angle? How do I recognize one over the other?
There's usually a line in the horizontal arc.
How do I recognize one over the other? Where's the vertex on the central angle? The center. Okay. Okay, and they're going to do both on you. Okay. So in other words, oops. That would be a central angle.
So the point.
So what would that be?
That's
What's the degrees of that angle?
100.
100. Okay, central angle has the same measurement of its arc
Right.
versus an inscribed angle where the vertex is actually on the circle. It is half of the inscribed arc.
So central always comes from the center,
Right.
and inscribed always comes from the
From the
edge.
point on the outside. Correct. Correct. Okay, now this becomes really big, and it's so they waste a lot of effort here, I think, because they want to show you something. The inscribed, okay, I can have like that as an inscribed thing, so it can go right through the center, doesn't matter. It's still half of that arc. I can have it where the center point is in the center, and it's still half of that arc. I can have it where the two lines are out here on the other side, outside the center point, and it's still half of that arc. Okay, so it's always, if it's an inscribed angle, I really don't care where the center point is. It's always going to be half of the arc that it inscribes. Now, it's never going to give you something real easy. It's going to give you a complicated circle where you have many arcs in the circle. So, for instance, these are actually kind of fun, but you have to be very careful in how you look at them. Okay, the O is not on either of these lines. All right, I know that AB, this is from A to B, is 140. I know from B to C is 100, and I know that MD equals DC. Now it really doesn't look like it, but that and that are congruent. It really doesn't look like it even in the book. Okay, so now I've got to find all these angles. Angle 1, angle 2, angle 3, angle 4,